Okay, so good to have you guys. So in today's tutorial, I'm going to talk about what we call factorials. All right, so what is a factorial? A factorial is it's a mathematical concept. It's normally denoted by this notation 5. Let's say I want to check out the 5 factorial. So we normally say 5 and then the exclamation mark or the exclamation point. This is 5 factorial. So what does this mean? This means 5 times 4 times 3 times 2 times 1. So you can see the pattern here. Each time we're reducing this number by 1. Okay, so we go 5 minus 1, we get 4, minus 1, we get 3, we get 2, and then we get 1. And then we have to stop when we get to 1 because this is the base case. So 5 factorial is a product of these numbers. 5 times 4 times 3 times 2 times 1. Okay, so what do we get? 5 times 4 is going to be 20, times 3 is going to be 60, times 2 is going to be 120, times 1 is going to be 120. So 5 factorial is going to be 120. So as you can note the pattern, so we can choose any number. Let's say 4 factorial. So what is 4 factorial? Which is 4 plus exclamation point. This is 4 times 3 times 2 times 1. So what is this? What is the answer to this? 4 factorial 4 by 3, which is 12 by 2, 24 by 1, which is 24. Okay, so I want you to notice one thing. So when we say 5 factorial, we could actually say 5 factorial is 5 multiplied by 4 factorial. We can say it's 5 multiplied by 4 factorial. We can say that. So if we multiply this 24 by 5, so 5 by 24, 5 by 24, we could still get to 120. So that means 5 factorial is 5 multiplied by 4 factorial. So what is 4 factorial? It's 4 multiplied by 3 factorial. Okay, so that's how we come up with these factorials. Okay, so I want to talk about implementations now. Alright, so how do we implement this in Python? I'm going to use 3 ways that we actually implement. There could be more ways to implement it, but I'm just going to show you 3 ways for today. Alright, so the first way we implement the factorial is I'm gonna create a function called fact and I'm gonna use a for loop. Okay, so the first thing we want to do is create a variable called res, and then we assign it a value of 1. Okay, and then we use a for loop for x in range 1, because the base case is 1 and then up to that number, so we say n plus 1. For those who know how the range function works, it starts from this is the start and this is the end, but it's exclusive of the end. Okay, it's not part of it. So n plus 1, let's say we pass in 5, so we getting up to 6, so it doesn't get up to 6, it gets up to 5. Okay, so here we want this raise to be equal to raise multiplied by x. Okay, is this the x? Yes. And then eventually we want to return raise here. Okay, so I can implement this. I can print the factorial of, let's say, fact of 5. Control S, Control B. You see down here I have a 120. Okay, this is the factorial of 5. Factorial of 4. Try it one more time. We can see this is 24. Okay, the same way we were doing up here. All right, so let's move on to the second implementation. I'm going to comment this out. Second implementation is using the while loop. Okay, it's almost the same as the for loop, but it's kind of different. So I'm going to define a method called factorial here. Passing n is the same as this one, but there are 2 ways. There are 2 variables that you have to to create in the beginning. So x is equals to 1 and then result is equal to 1. You can call this whatever you want. So we say while x is less than or equal to n. What do we want to do? We want result to be equal to result multiplied by x. It's going to be multiplied by x. And then we want to increase the x. So x is equal to x plus 1. And then eventually we want to return the result. Okay, so I can print this and check out if it's working. Factorial or 5. That's what we're testing. Okay, Control S, Control B. As you guys can see down here, it's 120. Let's check out the factorial 4. Control S, Control B, it's 24. Yeah, perfect. So it's working. All right, so we're done with this method, with this function. So we already have 2 functions. I still have one more function to show you the implementation of the factorial in Python. So this is the first function that we created, the second function. So these are 2 ways that we can do it. The third way is by using what we call the recursion. Okay, recursion is just a function that calls itself or calls another function in its body. Okay, so we're gonna define this as let me see the names of these. We don't want a clash of names, so I'm gonna use facts to just differentiate the names. I'm gonna pass in n the same way, and then here we have to implement the base case scenario. So if n is equal to 1, we want it to return 1. If n is less than 1, we want it to return invalid input. You're not passing anything less than 1. Okay, and then else we want to return the n times the facts of n minus 1. All right, so I explained this earlier on when I was explaining about the 5 factorial and the 4 factorial, and I said for us to get the 5 factorial, we can say 5 times 4 factorial. So this is what's going to happen here. It's going to be 5 times factorial of 4, or 5 times factorial, 4 times factorial, 3 times factorial of 2, because if you pass in 5 here, it's going to be factorial of 5 minus 1, which is 4. Okay, so it's going to be factorial of 4 or factorial of 3. Okay, so I can implement this. I can test this out. So if I want to check if this is working, I can use the print statement here. Let me print. If I hit the base case, I want to print I am the base case. Okay, so we print I'm the base case, and then here we want to print. We want to see if it's really looping through. So we can say I am recurring, and then we pass in the n. Okay, here. So we can check this out, and I'm gonna call this function down here. So print facts of 5. This one, this is the function that we're calling. Control S, Control B. As you guys can see here, this is the implementation and this is the result. I'm recurring 5. The first time it's 5, and then it goes again, it becomes 4, 3, 2, and then it hits the base case. Once it hits 1, it goes to the base case. 1 is the base case, and that's it. And then we get a 120 here, the outcome, or the output of this function. So these are 3 ways that you can implement the factorial. All right, now let's talk about the importance of the factorial. Why is it important to know the factorial of a given number? Okay, so we know the factorial. It helps us to calculate the number of ways that we can, arrange items in a given list. Let's say we have 5 elements in a list. It simply means we can rearrange those elements 120 times. Okay, 120 times. So I can prove that. Let us import a library or a module called itertools. It allows us to do iteration, and it also allows us to calculate permutations. All right, so down here, what I'm going to do is down after this this function call, we have to create let's call these letters, and then we pass in creating a list. These are elements in a given list. We want to see how many times they can be rearranged. So C, and then we have D. So for a start, we're going to start with 4 elements. So we say if we have 4 elements, these elements can be rearranged 24 times. That's what the factorial says. It says 24. So is it really true that we can rearrange these 24 times? We can check it out using these itertools. So now after this, we want to call an object, create a variable called mix, and then we call itertools. And then in itertools we access a method called permutations, and then we pass in the letters. We pass in this list here. So this is going to calculate the permutation, the different permutation that we can have. Okay, the different ways that we can rearrange or remix these letters. And then once we have itertools, we can iterate through this variable that we created. Is more like an object. Okay, so we can iterate. So I can use a for loop for x in mix, this mix. Okay, so we want to use indexing. We want to count as well. So I'm going to create a variable called count here, and then what I can do here is to enumerate. I use a method called enumerate. That's going to help me to count. Okay. This enumerate allows me to call this count down here when I'm printing out, and then I can start from I can always start from 1. Okay, when I'm counting, I want to start from 1, and so when I'm printing this, I can print the count and then the x. Okay, so I'm printing the x, which is the values that I have for this one, for these permutations, and then I'm counting like 1, 2, 3, 4, 5, 6, 7, 8, 9, you see. All right, so okay, Control S, Control B. Okay, down here, I want you guys to see. Do we have 24? Okay, this is 4. Okay, these 4 elements. Let me pass in 4. All right, so it says 4 here, 24. This is factorial of 4. If we have 4 elements in a list, they can be, rearranged 24 times. That's what the factorial calculates. And so is it true? Yes, we had 4 elements. I used the permutations method in itertools to check how many permutations we can derive from a given list of 4 elements. Okay, so it says you can have 24. That's what this part is calculating, and this is the output down here. All right, let's assume we add in one more. Okay, let's say we don't have 4 elements, we have 5 elements. I want to see how many times. This still shows 4 because I haven't changed here. I haven't changed the list of elements, but here it says 120. All right, so let's add one more here, comma E. Now we have 5 elements, right, in this list. So we said the factorial help us to know how many permutations that we can derive from a given list of elements. So if we have 5 elements, the factorial help us to calculate the permutations that we can get. So the factorial says we can get 120. So we want to see if we can really get 120. So we have 1, 2, 3, 4, 5 elements. Now let's save this and run this and check it out. Boom, we have 120. So that's how important the factorial is. It helps us to know the number of permutations that we can derive from a given list of elements. All right, so I hope it's clear. If you have any questions, you can leave them in the comment section. This is a straightforward application, and I hope to see you in our next tutorial. For now, I'm out. I'll see you next time. Bye bye.